Hi everyone, this is session 2 of day 7 maybe I think, and we were right here on recap, and we'll do recap of choosing state structure, and then we will move to sharing state between components. Okay, so let's get started. Okay, recap. If two state variables always update together, okay, two state variables update together, like we wanna update one and we are updating the second one also, consider merging them into one. Okay, second point is choose your state variables carefully to avoid creating impossible states. Okay, structure your state in a way that reduces the chances you will make a mistake updating it. Avoid redundant and duplicate state that you don't need to keep in sync. Keep it in sync. Don't put props into state unless you specifically want to prevent updates. Okay. For UI patterns like selection, keep ID or index in state instead of object itself. Selection, keep ID or index in state instead of. Don't do redundancy right here also. We saw earlier. Okay, if updating deeply nested state is complicated, try flatten it or try images. Okay, the first challenge, I think, what's going on? This is clock component receives two props, color and time. Right here, it's props at time. Okay, when you select a different color select box, in the select box, the clock component receives a different color prop from its parent component. However, for some reason, the displayed color doesn't update. Why? Why? I think this state is unnecessary. We are adding props in a state, and then on select, there is a h1. Somewhere select is also implemented. In select we are passing props and we are putting it in a here state. Instead of doing this, we can do this. Start color, and now it will work, I think. Yeah, it's working. Let's go to next challenge. This packing list has a footer that shows many items are packed. 1 out of 3 packed, 2 out of 3 packed, 3 out of 3 packed. And it's working fine. What's wrong? Let's add one more item. One, two, three, four. It seems right. Nothing wrong with this list, I think. And how many items are there overall? It seems to work at first, but it is buggy. For example, if you mark item as packed and then delete it, what happened? The counter will not update correctly. Okay, 3 out of 2. Wow. Okay, got it. Now let's reset. Fix the counter so that it's always correct. That's I deleted 2 and 1 is remaining. 2 out of 1 pack, but there are nothing left. I think stayed is somewhere persisted. And this is a long code and understanding it will take some time, I think. Ignore this. This is just a data object. Initial item. Hmm. I mean, set total here is the initial items dot length, I think. Yes, I think here is any state in this example is redundant. Yeah, these two are redundant, I think. I mean, what's going on? Let me check the solution for now. Although you could carefully change. Okay, use. Oh, we can use dot length thing. Okay, total is length and packed item dot packed. Wow, we don't need any state even. Just one state variable is more than enough. Fixing disappearing selection. I mean, I think. Oof, doing this exercise will take little bit of time, but let's go. There's a list of letters in a state. Okay, what's going on? When you hover or focus on particular letter, it gets highlighted. Okay, it gets highlighted. Good. The currently highlighting letter is stored in highlighted letter. Oh, why you are using state here? You can star and unstar individual letters which update letters array in state. Okay. The code works with minor UI glitch. When you press star or unstar highlighting, I mean, wow, this dancing box is making stuff so irritating. The highlighting disappears for a moment, however, it appears as soon as you move pointer to uh, another letter or keyboard. Why this happening? Fix this that highlighting doesn't disappear after button click. I mean, why? Set highlighted signal. And for fixing this, I need to understand all of this code. Let's search the solution. You are holding a letter object highlighted color, but you are also holding the same information. I mean, I'm not interested for now. I mean, I know how to choose a state structure. I mean, there are a couple of rules which I need to keep in mind. I mean, I don't want to bother myself right now with examples. These are rules or guidelines to choose a state structure. Okay, sharing state between components. Sometimes you want the state of two components always change together. To do it, remove state from both of them and move it to their closest common parent and then pass down them via props. This is known as lifting state up, and it's one of the most common things you will do writing React code. How to share state between components by lifting it up? What are controlled and uncontrolled components? Okay. Hmm. Lifting state up by example. Mhm. Accordion panel. Each panel component has a Boolean ejective state that determines whether its content is visible. Press the show button for both panels. Okay, press. Okay. Now how passing panel button does not affect other panel. They are independent. Let's read this code. Hmm. Const is active. This is a panel. Set is active is equal to true, and this is a simple, not even a toggler. If we wanna make it a toggler, then we'll do. Let's selection and panel. Okay, we are rendering panel two times. What's wrong with this approach? This is good. Notice how passing one panel button does not affect another panel. The other panel, they are independent. Okay. Initially, each panel is active. Let me reset this. How the panel button does not affect another panel, they are independent. We learned earlier that each component state is independent. This is a component and this component is independent of above. Like I do show, this will not show. If somehow I am able to hide, this will not hide. Okay, but now let's say you want to change it so that only one panel is expanded at any given time. With that design, expanding the second panel should collapse the first one. How would you do that? To coordinate these two panels, you need to lift their state up and to parent component in three steps. Remove state from the child components. Pass hard-coded data from common parent. Add state to common parent and pass it down together with the event handlers. Okay. This will allow the accordion component to coordinate both panels and only expand at one at a time. We removed. Okay. You will give a control of panel is active and to its parent component. This means that parent component will pass is active to panel as a prop. Instead, start removing from this line from panel component. Pass the hard-coded data from the common parent. To lift state up, you must locate the closest common parent component of both the child components that you want to coordinate, or accordion closest common parent of both panels. Okay. In this example, accordion is a component since above both panels can control their props, it will become a single source of truth. Which panel is currently active, make accordion component to pass. Hard-coded is active true for both panels. Okay. Okay. Add state to common parent. Active index, set active index. This will be added in When is active index is 0, the first panel is active. When it's 1, the second one. Okay. The button inside panel will now on show prop. Let's click event handlers. Okay, this is cool. Let me see the whole code now. I mean, this is accordion, active index, set active index. Hmm. Active index. Hmm. I don't understand. This complete lifting state up, moving state from into common parent component allowed you to coordinate two panels using the active index instead of is shown flag is ensure that only one panel is active at the given time. Okay, Azan is happening and this is Azan break. So we are back and let's copy this and go to and remove this picture thing and put it here and try to understand code what's happening. Okay, why not run Korean instead of this? Let's Mm, okay. Okay, now this is accordion and this is panel. There are two components. Okay, the accordion is a parent component and the panel is child component. Okay, got it. Now we are passing on show set active index to 0. Okay, what magic they're trying to do is, if we are passing is active and on show. Okay, and on show, just we click on on show and on show will set active index to 0. If active index is already 0, then 0 is triple equals to 0, it's true, then this will be open and visible. Okay, and at the main time when is active index 0 is triple equals to 1 becomes false, this will become this will be collapsed automatically. And the same story for this, if this will be, we click this one, then this will be uh, set it to 1 and 1 is equal to 1 true, and this will be appearable visible, and this will become automatically false, and so this will be not visible. Okay, I can write like, I shouldn't write, I know, I think, and this is it. I mean, accordion active index is 0, so is active is true, show panel is false. How we are calculating is active is doing this. If this is 0, this will become true, and true will go here, like somewhere, where we're here, and in conditional rendering, and if this is true, then this will render this up next, JSX. Okay, controlled and uncontrolled components. It is common to call component with some local state uncontrolled. For example, the original panel component was with its active state variable is uncontrolled because its parent cannot influence whether the panel is active or not. Okay. In contrast, you might say component is controlled when the important information is driven by props rather than its own local state. This lets parent component fully specify its behavior. The final panel component with its active prop is controlled by accordion component. Uncontrolled components are easier to use within their parents because they require less configuration, but they are less flexible when you want to coordinate them together. Control components are maximally flexible, but they require a parent component to fully configure them with props. In practice, control and uncontrolled aren't strict technical terms. Each component usually has some mix of both local state and props. However, this is useful way to talk about how components are designed and what capabilities they offer. When writing component, consider which information in it should be controlled via props and which information should be uncontrolled via state, but you can always change your mind and refactor later. In React application, many components will have their own state. Some state may live close to the leaf component bottom to the tree like inputs. Other state live closer to the top of app like root. For example, even client-side routing libraries are usually implemented by sorting the current route in React state and passing it down by props. For each unique piece of state, you will choose the component that owns it. For each unique piece of state, you will choose the component that owns it. This principle is known as having a single source of truth. It doesn't mean all of state live in a one place, but that for each piece of state, there is a specific component that holds that piece of information. Instead of duplicating and shared state between components, lift it up their common shared parent and pass it down to children that need it. Your app will change as you work on it. It's common that you will move straight down or back up while you still figuring out where each piece of state lives in the all part of this all part of the process. To see what it feels like to practice, there are few more components read thinking in React. I think we did this. We'll read this later. Someday. Okay, recap. Only 27 minutes passed. I mean, and we covered two things. When you want to coordinate two components, move their state to their component common parent. Okay, then pass information down through the props. Finally, pass event handlers down that children can change the parent state. It's useful to consider components as control driven by props and uncontrolled driven by state. Challenge 1. These two inputs are independent. Make them, let's say, sync. Editing one input should update the other input with the same text. Oof, and vice versa. Let me just copy this or even cut this one and paste it right. I think here. Why I'm doing blindly? Because I know. Cut this right here and paste it right here. Now give me a call in input. And for now I'll do this. Handle change is equal to handle change. Oh, and let's say text is oh text is equal to somehow text and let's copy this one. No, let's copy these two and paste it right here. Now here we'll do this, and I think it should work now. Okay, this is working. Now when we change state is just one state, single state, and we are sharing same state to both of them. Okay, filtering a list. Let's skip this and go to another one. React build render tree for your component structure of UI. You give component state. You might think state lives inside component. Okay, then what? Then what? Well, here I have a concern. Right, in example, like why we thought earlier that each component holds their own state, but when we use state right here, now they're owning their own state. Okay, when we will lift it up, they will have same state. Okay, let's go to next one. Think. I mean, this is for now. I think these two sections, and for in next day morning, I mean, I'll do this. I'll complete this one, and then we will hopefully move to full stack open, because there are reducers and contacts which we haven't reached yet. And in full stack open, in full stack open, we were right here, I think. And the last section, this what's happening, man. Yes, the last section, more complex. Yes, right here. Now, handling arrays, we read updates. We read this really thoroughly, I think. I mean, how state is state as a snapshot and queuing a state and whatnot. Conditional rendering, we will go through this. Okay, debugging, React, or React. We will skim through this. I mean, okay. Then debugging React application, rules of hooks. I mean, we read this rules of hook, but we will go through again. A function that returns a function. May we know, do not define components within components. Okay. Useful reading. Utilization of LMs. And yeah, we reached eventually at official exercises. Okay. Okay, we are good to go for today. And yesterday we will. I mean, this is for it. I mean, next day we will go through other one. I think. Goodbye. I might not. I mean, really small.